Alright, let's continue with graphing quadratics here. So you see I'm trying out some new pre-prepared computer graphics here. We'll see how that works. Hopefully it'll make things a little neater. Okay, so let's start by just reviewing what we did in the last video. This was a problem we took a look at. Y equals x minus 1 squared plus 3. And what we do is we want to get this whole squared term equal to 0. So in order to make that happen, x is going to equal 1. And when x equals 1, this whole squared term will be 0 and y will be 3. So the vertex will be x is 1, y is 3. And we can plot that point on the graph. And then we just do the standard pattern of every time x changes by 1, first we'll go up 1, then y will go up 3, then it'll go up 5, so we'll be off the graph there. And then we just reflect that over the axis of symmetry, which is just the line going right through the vertex, the vertical line. And so it's the line that divides the graph in half. And then we'll end up with this curve, this bowl-shaped curve that Okay, so that's just a quick review. Now what we're going to be adding in this video is a coefficient in front of the squared term. So if you remember, the general form for this equation was y equals x minus b squared plus c, where the vertex is b comma c. As you can see here, we have x minus 1 plus 3, so the vertex is 1 comma 3. So the reason we use b and c and not, say, a and b is because a is going to be the coefficient in front of the squared term. So now the new equation of this more complex vertex form will be a times x minus b squared plus c. And the a is only being multiplied by the squared term, not the c. That is separate. So now let's take a look at this graph. Here, let me just rewrite this equation right there. And all we're going to do is add a 2 in front of the squared term. So now we have 2 times x minus 1 squared plus 3. So all this number does is it's going to raise the amount by, it's going to double the amount by which the y value increases, right? Because what we basically did was y equals 2 times everything else. We're still going to have the same vertex because when x is equal to 1, this whole thing is still equal to 0. 0 times 2 will still be 0, and then plus 3 will mean y is 3. So the vertex will still be x is 1 and y is 3. But now, as x increases, the y value is going to be growing twice as fast because we have 2 in front of this term with the x in it. So instead of going up by 1 when we move over by 1x, the y value will go up by 2. So you know what, let's use a different color to make this clear. The y value will go up by 2. And then, instead of going up by, here we went up by 3, we're going to go up by double that. We're going to go up by 6. So 1, 2, 3, 4, 5, 6. It will be way up here. Now for this one, going to the left, it's the same. Instead of y going up by 1, when we move over by 1, x is going to go up by 2. And then instead of y going up by 3, when we move over again, it's going to go up by 6. So up 1, 2, 3, 4, 5, 6. So this is basically the same graph, except now it's increasing twice as steep. Let me see if I can draw that in there so you see that it is increasing twice as steep. So it's much narrower in the center. Now what if we had the a term is -2? Well, what that's going to do is it's still going to be twice as steep, but now it's going in the negative direction. So we still, again, start at the same vertex right here, but now instead of going up by 2, we're going to go down by 2. And instead of going up by 6 on the next one, we're going to go down by 6. So same thing over here. Again, there's still the axis of symmetry is still the same. It still goes right down the middle on this line x equals 1. So we can reflect all of the points over it just like that. And we still have that steeper curve. So you see that the steepness of the curve, here, let me draw that a little bit better. So you see that the steepness of the curve here is the same as in the blue graph up here. But they're both increasing twice as steep as the original black graph. It's just this one is +2 and this one's -2. So this is twice as steep and in the negative direction. Okay, so now that we have this a term, we can have a number in front of the squared. That's going to change things up quite a bit. Okay, so before we do this graph, let's just review one thing. When we're plotting points, with the original graph here where the a term is just 1, the standard pattern by which the perfect squares increase, as we discussed in the last video, is +1, then +3, then +5, +7, just like that. So as you can see with the blue graph, what happened was all these numbers just doubled. So we went over by 1x, the y went up by 2. Then we go 1 more x, the y went up by 6. So all these numbers just doubled. So all you do is you take these numbers and you multiply them by whatever a is. So here, if a is 3, then these numbers will become 3, 9, 15, just like that. Those are the amounts we're going to increase by each time x goes up or down by 1. But before we do that, we first have to calculate the vertex here. So the vertex, again, just ignore the a, that doesn't matter. All we need to find is what makes the squared term 0. That's going to be x is -2. And when x is -2, all of this is 0, so y will be -6. And there's our vertex. So the vertex is always what you start with in this form. Now the only difference is instead of going up by 1, then up by 3, then up by 5, we're going to be going up first by 3, then up by 9, and then after that we go up by 15, so that's going to be way off the graph. So we're not going to plot that. Alright, now we just reflect these points over, and we draw our graph. So you can see here, with the 3, the graph got even narrower than it was with the 2. The larger the a term, the faster the y increases. So the narrower the curve is going to get. Okay, now let's add in something else that's new. Now we have a coefficient directly in front of x. Again, the first thing you always do is calculate the vertex. What's going to make this whole thing 0? So what's going to make 2x minus 6 equal to 0? Well, that would be if x were 3. we basically just solve the linear equation 2x minus 6 equals 0, and we get x equals 3. And when x equals 3, this is 0, so y is negative 8. There's our vertex. 3, comma, negative 8. Now, the a term here, well, it's not really the a term, but the amount that we're going to multiply these numbers by is going to be 2 squared, because the 2 in front of the x is being squared. It's inside these parentheses, so it's being squared. 2 squared is going to be 4. So we could actually, if you wanted to, you could rewrite this equation as y equals 4 times, and now you can construct it using this vertex, x minus the x-coordinate of the vertex squared minus 8. So all we did is we factored out the 2 of 2x minus 6 to get x minus 3. And when we factored it out of the squared, we just squared it. 2 squared was 4. So these are the exact same. So if you want to, you can rewrite it like this. This is what we're really going to be graphing now, where the first number here is 4. So when we go over x by 1, the y value increases by 4. And then after that, it's going to be 3 times 4 again. So that will be up 12. Now just reflect all these points over. If you have a little trouble reflecting here, you can draw in the axis of symmetry, the vertical line going right through the vertex. Or just remember, these two are going to be, since this was 1 to the right, and this was 1 to the left, they'll be 2 apart. So these two, this point over here is 2 to the right of the vertex. So now we're going to go 2 to the left. So 2 plus 2 is 4. So this is going to be 4 points away in the x direction, like that. 2 points away, 4 points away. That's an easy way to plot these points. So now that we had an a term of 4, this graph just keeps getting steeper and steeper and steeper. You can see here was 1 in front of the x, there's 2, there's 3, there's 4. So the higher the a value gets, the steeper the graph gets. But now let's take a look at something a little different than that. This time, instead of increasing the number in front of x, we're going to decrease it. We're going to have a fraction there. Okay, so again, first thing you always do is find the vertex. Get the squared term equal to 0. So if 1 half x minus 1 equals 0, then 1 half x equals 1, so x will equal 2. If x equals 2, this is all 0, and y will be 5. So the vertex is 2, 5. Now that you have the vertex, let's see how quickly y is going to increase. The 1 half in front of the x is squared. So the a here is really 1/4. But because we have a negative in front of the whole thing, it's going to be negative 1/4, which means the parabola is going to be pointed downward like that. So now we're going to take these numbers and multiply them all by 1/4. So we'll be increasing by 1/4, then 3/4, then 5/4. So we basically just divide them by 4. So we're going downwards, so we're going to be decreasing by 1/4. So it'll be just below where we are now. Then we're going to be decreasing by 3/4. So 1/4 plus 3/4 is 1, so that'll put us one whole y value lower. Then 5/4, so that'll be just over 1 lower. Then 7/4, that'll be going just under 2 lower. So we're back on a grid line here because we had 5/4 plus 7/4 is 3. So now, of course, you can keep plotting forever and ever and ever, but these are enough points that's going to give us a pretty accurate curve. So I think we'll stop there. Now just reflect these points over as best you can. And now you can kind of just guess the rest of it. Just try to draw as smooth a curve as possible. We graphed a lot of points there. Oops, it's not very smooth at the top. There we go. So now you see with an a term of 1/2 squared, or 1/4, the graph has gotten a lot wider. So when you have a number less than 1 in front of x, the graph gets a lot wider. Alright, this next one might look pretty crazy at first. But remember, the first thing you always do is find the vertex. So here we want to get 1/4 x plus 1/2 equal to 0. If it helps you to write out that equation, you can most certainly do that. Now to solve this, we might want to multiply everything by 4 to get rid of the denominators. We'll get x plus 2 equals 0. And now we can very easily see that x is -2. So if x is -2, everything here is 0 except for -1. So y equals -1. So that is the vertex, -2, -1. Now, what is our a going to be? How much are we increasing by? Well, 8 is positive, 1/4 is positive, so we know it's going to be a positive number, which means the parabola is going to be curving upward. So 1/4 is being squared, 8 is not. So we have 8 times 1/4 squared. 1/4 squared is going to be 1/16th times 8 will be 8/16, which is 1/2. So we're going to be multiplying these numbers by 1/2. So we'll get 1/2, 3/2, 5/2, 7/2, just like that. So first we go up by 1/2, then we go up by 3/2, then we go up by 5/2. That should be enough points to get a pretty good curve. So now just reflect those over here and draw on the curve. There we go, that wasn't so bad. So you can see here that with 1/2 as the a, the graph is wider than a standard parabola with no coefficient in front of x, but not quite as wide as 1/4 up here. Okay, now what I'd like to take a look at is stick with this graph, but we're just going to change this equation here. Let me write it right above here. We're just going to make one small little change. In fact, let's do it in a different color to make it clear. So the only change we made is that we put a negative in front of the 1/4 here. So you might assume that that's going to make, that since it's in front of the x, that's going to make the graph flip upside down and will now be going downward since a is negative. But remember, we have negative 1/4 being squared here, and a negative number squared is positive. So here we have negative 1/4 squared is positive 1/16 times 8 still gives us 1/2, exactly what we had before. So the graph is still going to be pointing upward with a steepness of 1/2. What's going to change is actually the vertex. Because now, in fact, let's just do it right here. Now we have negative 1/4 x plus 1/2 equals 0. So this will become negative x plus 2 equals 0. And x will now be positive 2. So what that does is the vertex is now positive 2, negative 1. It's right there. But we still go up in the exact same way. Basically, all of the points are just getting shifted. Everything's just getting shifted over by, it looks like, 4 points. So we can just mirror what we already did. And that's good enough. We don't have to draw every point. And it's going to look something like that. So you can see that it's the exact same graph, just shifted over to the right a bit. The only thing that changed was the x-coordinate of the vertex. So the lesson there was just don't be fooled by a negative number in front of x. If it's inside the parentheses and being squared, it's going to go back to positive, and the graph will still be pointing upward. Okay, now let's just do one last problem that combines together everything we've covered here. Okay, so first thing, calculate the vertex. Negative 3x minus 18 equals 0. Let's see if we can do this in our head. We'll move the negative 18 over to the other side. We'll get negative 3x equals positive 18, so x will be negative 6. All of this will become 0 when x is negative 6, and y will be positive 4. So there is the vertex. Right there. Now, what is the steepness here? Well, we have negative 1/3 times negative 3 squared. Negative 3 squared will be positive 9 times negative 1/3 will be negative 3. So we're pointing downward and the steepness is 3. So that's what we start with. We start with, when we move over by 1x, we start with going down by 3. And hopefully you remember the pattern by now. The pattern was 1, 3, 5, 7. So multiplied by 3 is going to be 3, 9, 15. So we went down by 3. Now we're going to go down by 9. Like that. And then just copy those points over onto the other side. And there is our nice and steep curve. Okay, so we are done with vertex form of quadratics, but there are several other forms that quadratic functions can be in, and we have to learn how to graph starting with all those forms. So we are definitely not done with graphing.